Good afternoon, class. We are looking at chapter 8. Further application of trigonometric functions, section 8.1, the law of sine. So we're going to look at the law of sines, the law of cosines, polar coordinates, equations and graphs, polar forms of complex numbers, vectors, the objectives of this section. Solve SAA or ASA triangle, solve SSA triangle, solve applied problems. SAA, side angle, angle, side angle, side angle. That's what they stand for. Reminding you of the unit circle. X squared plus y squared equals 1. A pair has coordinates x comma y. X is cosine, y is sine, and the rest of them follow. Every trigonometric function is an odd function, meaning f of minus x equals minus f of x, except cosine and therefore secant. And these are fundamental identities, Pythagorean identities, quotient identities, reciprocal identities, and in the case of a right triangle, a squared plus b squared equals c squared, Pythagorean theorem, and a plus b must add up to 90 degrees. Reminding you of the sum and difference formulas, double angle formulas, solving for sine squared and therefore half angle formula, solving for cosine squared and therefore half angle formula, and tan is sine over cosine. And these are the half angle formulas. You have to figure out the sign, positive or negative, based on the quadrant they belong to. The right triangle, as was mentioned, a squared plus b squared equals c squared, a plus b equals 90 degrees, and we define sine as the opposite over the hypotenuse. In this case, for b, would be b over c, and cosine is the adjacent a over c, and the rest of them follow. Tangent is the opposite over the adjacent, the rest of them are the reciprocals. Now, if this is the horizontal side of line or horizontal plane, angle of elevation basically looking up, angle of depression basically looking down. Definition, angle of elevation is the angle formed by the line of sight and the horizontal plane for an object above the horizontal angle of depression is the angle formed by the line of sight and the horizontal plane for an object below the horizontal. So angle of elevation versus depression. Also, a bearing. A bearing is used to represent the direction of one point relative to another point. Method 1. The direction or bearing of a point is the number of degrees in the angle measured in the clockwise direction from the north side. So north, just clockwise angle. That's all. So just mention the angle. From the north vertical line to the line joining the center of the compass with the point, or the second method. Direction of bearing of a point O to a point P equals to the acute angle theta between the ray OP and the vertical line through O, the north-south. So you consider the closest angle either to the north or south. To the right of it is east, to the left of it is west. For the sake of argument, if you look at P1 would be north 30 degrees east, whereas P4 would be south 20 degrees east. So that's how we do that. And now 8.1, the law of sines. Solving oblique triangles. What do we mean by oblique triangles? None of the angles is a right angle. That's the definition of an oblique triangle. So it could be that all of them are acute. What do we mean by that? We're going to discuss that. Or you have two acute and one obtuse angle. Okay. Acute angle A is between 0 and 90 degrees. So all of those are between 0 and 90 degrees. Obtuse is larger than 90, but it has to be less than 180. So B is between 90 and 180. So this one is between 90 and 180. And of course, those two must be between 0 and 90 degrees. And if we look at this example, B, of course, clearly larger than 90 degrees. That's an obtuse angle. A and C are both acute angles. The sine law indicates that sine A over A equals sine B over B equals sine C over C, or you can write the reciprocals. And we're going to look at the proof shortly. And of course, as always, A plus B plus C, they add up to 180 degrees. If you add all angles, the interior angles, they must add up to 180 degrees. So here's the sine law as it was mentioned. Sine A over A, sine B over B, and sine C over C are equal. So cases of solving oblique triangles, and again, reminding you it means none of the angles are a right angle. If that happens, what do we come up with? ASA, angle, side angle. Maybe two angles and the side in between is given. Side, angle, angle. So the side is not in between the two angles. Side, side angle. Maybe two sides are given and one angle. In these two cases, two angles were given. It could be that side, angle, side, the angle is in between the two sides. So one angle is given, this one, the angle is in between, this one, the angle is not in between. Finally, maybe all sides are given. These are various cases that we come across, and we want to see how we approach those. Solving the oblique triangle case one, where we have two angles and one side. ASA angle, side angle, and SAA, side angle, angle. One side and two angles in both cases results in one unique solution and one unique triangle, basically one answer. Case two, side, side angle. SSA, side, side angle, two sides and an angle. Opposite one of them would result in several different situations and solutions to occur. Consequently, side-side angle is referred to as the ambiguous case. So anything can happen. We will look at various possibilities. Well, in this case, if A is acute and A is equal to the H, the height, one triangle exists. In fact, it's a right triangle. In this case, if A is acute and the B is larger, H is larger than B, larger than A. So in other words, A is the largest side and then B, and H is in between. one triangle exists. So H, in other words, is smaller than both of them. If A is obtuse, larger than 90 degrees, and A is larger than B, one triangle exists. In these two cases, if A is acute and A, one side is less than H, it can't happen. No triangle exists. If A is obtuse, larger than 90 degrees, and A is less than or equal to B, same thing, no triangle occurs. And the reason actually is very simple in this case. The side opposite an angle, the larger the angle, the larger the side opposite that. So the largest side should be A because it's opposite the obtuse angle, which is the largest angle. So it doesn't work. In this situation, H is less than A and A is less than B. Since A is larger than H, a triangle is created. But since A is smaller than B, it can swing to the left of H and create a second triangle containing an obtuse angle. What do we mean by all of this? We will look at various cases and try shortly. Case number 3, side angle side. SAS, side angle side, two sides and the included angle, the angle in between results in one unique solution and one unique triangle. There will be one answer if we have two sides and the angle in between. Case 4, solving oblique triangles SSS. Side, side, side. Three sides result in one unique solution and one unique triangle, as long as one side is smaller than the sum of the other two sides. And of course, we have to go with the next section, cosine law. So any side that you pick, it has to be smaller than the sum of the other two. Otherwise, it doesn't work. Let's look at the proof of the sine law or the law of sines. As we mentioned, sine A over A, sine B over B, sine C over C, they are identical. So you can pick any two if you want. When we put them all together, when we put all of those together, 1, 2, and 3, we get sine A over A equals sine B over B equals sine C over C. I hope you see that. So let's see how that thing works. This is a triangle of interest. This angle B, if we look at this angle and this small triangle, this one. Sine of this angle is the opposite H over the hypotenuse C. Which means H is the product of these two. By the way, lowercase c represents the side, uppercase represents the angle. Now, this angle, and we talk about the right side, the larger one again, remember both of them are right triangles. So this one, if I want the sine of this angle is the opposite H, but this time the hypotenuse is B. And so H is the product of these two, B sine C. And because both of them are h, that means c sine b must be equal to b sine c. Both of them are h, right? Now let's divide both sides by b times c. Divide both sides by b times c. We want to get rid of the c and we want to get rid of the b. So we're going to divide both sides by bc. So what happens? The c drops here, the b drops here, and we get sine b over b equals sine c over c. In other words, we get this one. All right, let's continue. Let's repeat the same process with the altitude drawn from point B. So what we did here from point A, we dropped the perpendicular, that was the height. Now from the B, we are going to do that, creating, of course, a 90-degree angle. And so A, if I want to calculate sine of A, again using the smaller one. Okay. Sine of this angle is the opposite, which is h over the hypotenuse, which is c. Cross product will give us h. H is c sine A. And now if we go to this one, so we are looking at this triangle, and sine of this angle, C, is the opposite H, but this time over the hypotenuse, opposite the 90-degree angle. The hypotenuse is A, so H over A, and cross product will give us H again. And of course, since the two are equal to H, then they must be equal. Now, because this is lowercase c, this is lowercase a, let's divide both sides by AC, everybody, AC. So in this case, c drops, we get sine A over A. In this case, A will drop, we get sine C over C. And take a look at this one, meaning what? Meaning the law of sine. Sine A over A equals sine B over B equals sine C over C. So that's the proof, everybody. You're not responsible for the proof. If you follow it, it will make it that much easier to understand the concept. So in this case, we want to solve the triangle using sine law to solve SAA, side angle angle. A is 40 degrees, B is 60 degrees, lowercase a is 4. This is A up, so this is capital A, everybody. Let's just quickly do that. This is A, B, and this side is C, capitals. So obviously, we have two angles subtracted from 180, you get the third angle. This is the fastest way to start it. So 180 minus the sum of those two. This is 100, that's 80 degrees, so we found this one. That's very easy, everybody. And according to the sine law, we can use any of them. By the way, you can use the first one and the second one, first one and third one, second and third, doesn't matter. So we choose to go with sine A over A and sine B over B, so because A and B are given. Okay, so you try to work with what is given. And of course, lowercase a is given. So sine of 40 over 4 sine of 60 over b, which we don't have. Now, I hope you recognize the cross product, b times this, 4 times that. So b becomes the product of these two divided by sine 40. This is a simple, let me just show the cross product. The product of these two and the product of these two are the same. So b is 4 sine 60 over sine 40. Although sine 60 is square root of 3 over 2, and we know that, we don't know sine 40. So we're going to put this into a calculator. And normally, they tell you how many decimals. And in this case, let's go with a couple of decimals. 5.3, 8 changes to 9, plus 8 next to this 9. So 5.39. In some cases, they say, okay, this has one, it is given with no decimal, so just add one decimal, but just follow the instruction. We are going to do, now that we have that side, let's make a note of it, 539. We are going to go with the second part, sine A over A, sine C over C. And by the way, although you can use sine B over B, I recommend you use what is given, because what if we made a mistake with our calculation here? Always try to go with the given. So this is sine of 40 over 4 sine of AD over missing lower C, and again, cross product 4 times sine AD equals C times sine 40, which makes C 4 times sine 80 over sine 40. You put it into a calculator, just as we did here, and it gives you the answer. So lowercase c is 6.13 roughly. So that's how you calculate this. A quick recap. Since two angles are given, the first step is to find the last one, because there are only 3 and total is 180 degrees. And because one side is given, you use the sine law with the given side and to find other missing side. So side, angle, angle. Example 2, solve the triangle A equals 35 degrees, B equals 15 degrees, lowercase c equals 5, and we're going to use the sine law to solve ASA, angle, side, angle. So as we look at this one, we see the angle, one of them, and the second one, and we see the side in between the two. That's why the side is in between. And so this is lowercase c equals 5. This is angle B. This is angle A, and this is angle C. So obviously, we add the two angles, we subtract it from 180. That's the fastest and easiest way, right? So they add up to 50, subtract it from 180, and we find the missing angle to be 130 degrees. Okay, so C, angle C is 130 degrees, everybody. Since we have lowercase c, that means we are going to use sine c over c, and then it doesn't matter which one you go with. For example, the first one, sine a over a equals sine c over c, okay? And that makes it sine of 35 degrees over missing A, sine of C, that means 130 degrees over 5. And cross product means A times sine of 130 is 5 times sine of 35. So 5 times sine of 35 divided by sine of 130 is the answer. Just as we did last time, we have to put it into a calculator. They are not common arcs. You put it, and with a couple of decimals, you approximate it to be 3.74. So A is found to be 3.74. And now we are going to use this part, everybody. Sine B over B equals sine C over C. In other words, this right side doesn't change. This left side, sine of B, means sine of 15 degrees. Lowercase b is missing. Cross product. So b times sine of 130 is the same as 5 times sine of 15. So b is 5 sine 15 divided by sine 130 degrees. Again, you have to put it into a calculator, everybody. We put this into a calculator. It results in 1.69. And we replay, we say b is equal to 1.69. And we have all the sides, all the angles, and we are done. All right. So we looked at cases involving two angles and one side, and they did work. And in each case, we got one answer. Let's look at side-side angle triangles, the ambiguous case. Side-side angle, case number 2, we have two sides and an angle opposite one of them. So let's look at various situations, see what happens. As you can see, this side is a right triangle, and sine of A is the opposite H over the hypotenuse B. H is B times sine A. If you do the cross product, everybody. 1 times H, B times sine A. So H is the product of B and sine A. What happens? Well, if A is less than H, if A is smaller than H, clearly we don't have any triangle. It doesn't work. So if A is less than H, which is equal to B sine A, it does not work, everybody. However, if this B times sine A is less than A, also less than, and of course, A is less than B. In other words, these two sides are not equal, okay? and B sine A is less than A less than B, this distance, everybody, let me drop a perpendicular. This is H. When that happens, the possibility would be this large one or this one. So I want to make sure that you understand the second one is this one. Either the entire triangle that you see or this one, which means there are two possibilities, everybody. That's why it's called the ambiguous case. Now, what happens if H is equal to B times sine A? H equals B sine A. If A is larger than B or equal to B, that works out. If A is equal to H equals B sine A, we end up with a right triangle. When A is equal to H, then it becomes a right triangle. So there is one possibility. And over here, A larger than or equal to B, that ends up giving us one triangle. So as I mentioned, this is known as the ambiguous case, and we will look at various examples of that. All right, let's look at example 3. Using sine law to solve side-side angle. Okay. There are three possibilities. We are looking at one of the possibilities here. Which one? We'll find out in a moment. A is 3, B is 2, and A is 40 degrees. Let me put capital A here. And although it says B here, but let's just write it a little bit bigger. And this is C. Those are the vertices, okay? And so maybe this is A. This is B. So we have 3 of them and the other 3 are missing. So we are going to use the sine law to find one of the angles. So because we have 2 sides. So since lowercase a and lowercase b are given, we are going to go with these 2, everybody. I'm going to go with these 2. Sine a over a equals sine b over b. So sine a, sine of 40 degrees, over lowercase a 3, sine b over lowercase b 2. cross product. 3 times sine B, 2 times sine 40 are equal. Therefore, sine B is 2 times sine 40 divided by 3. Again, not a common arc, not a common angle. You have to put that into a calculator. And with a little bit of a decimal, how many? You got to follow the instruction. You get 0.43. Now, it's extremely important because we want to find B to really keep this with many decimals because you're using a calculator. So because sine B is given, then B would be sine inverse of this number. Now, and everybody remembers sine is positive in the first as well as the second quadrant. And in both cases will be less than 180 degrees. So there are two possibilities. So B is a sine inverse of 0.43. I'm going to call it B sub 1, the first possibility. Now, when you put this into a calculator, please don't put 0.43. Put whatever that you found through this process, which has many decimals. When you do that, it gives you 25.4 degrees. And remember, again, sine is positive in the first and the second quadrant. So this acts as the reference arc as well. So this is not only the angle, also it works as a reference arc. So the second possibility in the second quadrant would be 180 minus this number. 180 minus 25.4 becomes 154.6. Subtracted from 180. This doesn't work. Why not? Well, the interior angles must add up to 180. We do know one of them is 40. When you add these two numbers, 40 plus 154.6 is larger than 180. That doesn't work. If the sum is less than 180, if the sum is less than 180, then this works, and that creates the second set of a triangle. This doesn't work. We have only one triangle because one of the angles work. That's why it's ambiguous. So what happens here? Three things happen. Number one, you have a case where you have two angles. This one doesn't work because it goes beyond 180. Number two, this number happened to be in such a format that both of them work. That means the sum of these two numbers is also less than 180. The third case is this number is larger than 1 and sine can't be, and it fails to have any answer. That's what happens in an event. So this is out because the sum is larger than 180, it's out. Let's just continue working with this. Now we have 1 to be 25.4. We add these two and we subtract it from 180. Let me erase my work. So add these two. So the last one would be 180 minus the sum of these two numbers. 180 minus A minus B1. That means 180 minus 40 minus 25.4, and that results in 114.6 degrees. So we have this angle, 114.6 degrees. Now we use it with the third one, this one and the third one, sine A over A, sine C over C. You can use any of them you want, but you have to use this one to find the rest of them. And so if we go with sine A over A, that means sine, just like this one, sine of 40 over 3, sine C over C, that means sine of 114.6 over lowercase c. Cross product. So 3 times sine of 114.6 is the same as c times sine of 40, which means c is the product of these two divided by sine 40. Again, you have to go with the calculator, plug it in. 3 times sine of 114.6 divided by sine of 40 degrees. That gives you 4.24. So everything is known. So we get 40 degrees here, 25.4 degrees here, 114.6 degrees here. So those are the only three angles. There's nothing else we can do. The sides were 2 and 3, and we found the last one as well.